We have walked on the moon, built tunnels under the ocean, and constructed skyscrapers that pierce the clouds. Yet, there is one ancient structure that still makes today's top structural engineers sweat. What would happen if we tried to build an exact 6 million ton replica of Khufu's Great Pyramid today, in 2026? This diagram shows the overwhelming volume we are dealing with. We have to perfectly stack 2.3 million individual stone blocks to create a solid mountain of rock 147 meters tall, sprawling across 12 acres. Executing a mega project of this size would completely max out modern global supply chains. We would need the absolute limits of heavy machinery, constant logistical coordination, and billions of dollars in raw materials. The Great Pyramid is an economic and logistical nightmare. Attempting to recreate it today exposes exactly how much we rely on modern conveniences and how difficult it is to match an ancient feat of brute force engineering. You cannot put 6 million tons of rock directly onto soft desert sand. The sheer weight would cause the entire structure to instantly sink. We know this because the ancient Egyptians learned it the hard way. Sneferu's bent pyramid is visibly warped because the bedrock beneath it lacked perfectly stable support, twisting its top half during construction. To avoid that collapse, we have to secure 13 acres of highly stable land on the Giza Plateau itself. Purchasing that specific terrain and the necessary legal permits will cost us $120 million. We must perfectly laser level the ground. A 1 millimeter error at the base means a 14.7 centimeter tilt at the top. To lock in this precision, we spend $400 million pouring a 4-meter thick concrete mat. This requires 500,000 tons of concrete to mimic solid bedrock. So before a single block of stone is even cut, our modern replica is already 3 years behind schedule and $550 million in debt just to secure the dirt it sits on. Now we face the materials bottleneck. If a standard modern stone factory started cutting the 2.3 million required blocks today, it would take them 63 years to finish the job. To finish in 5 years, we have to spend $50 million deploying an armada of 250 industrial diamond wire saws directly into the quarries. A diamond wire saw is a heavy-duty cutting cable laced with industrial diamonds, used specifically to slice through massive rock formations. This graphic tracks the hidden energy cost of that machinery. Running those saws requires 20 megawatts of continuous power. That is $155 million in electricity alone, just to slice the rock. Next is the challenge of moving $1 billion worth of stone from the Aswan quarries to Giza, a relentless 900-kilometer journey across the desert highway. To keep up with the construction schedule, we need 2,400 trucks making 132 trips every single day. That means 500 heavily loaded semi-trucks must be in constant motion for 5 straight years. The effort to secure these stones creates one of the largest and most expensive continuous supply chains in modern history. The final and most dangerous phase of construction is assembly. We have to stack 60 to 80-ton granite blocks 147 meters into the air to build the inner chambers. This schematic outlines the fundamental physics problem with modern lifting equipment. Cranes rely on a fulcrum, the pivot point where the machine balances its heavy load. As the horizontal arm extends outward over the wide pyramid shape to reach the center, its weight-lifting capacity drastically drops. To solve this, we must build a $300 million specialized network using the world's largest tower cranes. Because the pyramid tapers inward, these massive machines must be constantly disassembled and elevated as the structure rises. We also have to factor in the human and aesthetic tolls. It will cost $400 million to sustain an army of 3,000 workers, plus an additional $250 million for the 115,000 blocks of blinding white limestone needed for the smooth outer casing. Assembling the structure is a brutal battle against gravity that stretches the absolute limits of heavy lifting physics and modern safety protocols. Add up the land, the foundation, the cutting, the transport, and the cranes, and the highly conservative modern invoice comes out to $2.95 billion. For perspective, that is roughly the same construction cost as building a state-of-the-art NFL megastadium or dredging the massive artificial Palm Jumeirah Island in Dubai. Yet, the ancient Egyptians achieved this exact scale without diamond wire saws, diesel semi-trucks, or a multi-billion-dollar mechanized supply chain. This nearly $3 billion price tag reveals the immense scale of the ancient achievement. Even with our most advanced lasers and industrial saws, matching the precision and speed of the original pyramid remains an engineering challenge that pushes our modern infrastructure to its limit.